Good morning and welcome to Econometrics. Today we learn linear regression model. Let us first discuss the meaning of regression and then we can construct a regression model. Let's begin with a simple example. A variable, say variable y is determined by other variable, say variable x. This relationship shows that any change in x leads to a change in y. And let's move forward. Let us express this relationship in a mathematical form. This like y is equal to beta 1 plus beta 2 x. This hypothetical mathematical relationship that links an x and y is known as regression. In this regression model, y and x are variables and beta 1 and beta 2 are parameters. In other words, in this regression model, y and x are variables and beta 1 and beta 2 are the parameters. And the objective of the regression analysis is to find the average value of y given the value of x. Once more, our objective is to find the average value of y given the value of x. We begin with y is a f of x. Here y is known by different names such as dependent variable, regression or explained variable. X is known as independent variable, regressor or explanatory variables. X is equal to beta 1 plus beta 2 x. In this regression model, there is only one explanatory variable, say x. Since there is only one explanatory variable or one regressor, this model is called a simple regression model. It's a simple regression model. If there are more than one explanatory variables, that is a multiple regression. So now we have a simple regression model because there is only one explanatory variable. Consider the parameters beta 1 and beta 2. Both parameters take the power 1. Both parameters take the power 1. Therefore, this equation or this model is a linear model. This is a linear model. So, therefore, y is equal to beta 1 plus beta 2 x is a simple linear regression. Let us consider the regression model once again. Y is equal to beta 1 plus beta 2 x. And now we are going to give a subscripts to both the y and x. That yi is equal to beta 1 plus beta 2 x. The subscript I represents the ith observation. That is, yi means the value of y or the ith value of y and xi means the ith value of x. And in this model, you can see that the dependent variable y and independent variable x keeps an exact relationship. But you know that there is no exact relationship is keeping between the economic variables. So In order to show the inexact relationships between x and y, we can explicitly include one more variable u to this regression model and expand it to yi is equal to beta 1 plus beta 2 xi plus ui. Here y and x are the variables and beta 1 and beta 2 are the parameters and ui is the error term. And in this equation, this part of the equation yi is equal to beta 1 plus beta 2 xi is known as population regression. Here the values of yi and xi are observable, can be measured. Therefore yi and xi are the observable variables and this variable, that is the random variable ui, is an unobservable variable because its value cannot be observed. And beta 1 and beta 2 are the parameters of the model, are also known as the regression coefficients, and then beta 1 is the y-intercept and beta 2 is the slope coefficient. Here you have to remember one more point, that the true population values of beta 1 and beta 2 are unknown. The aim or the objective of the regression analysis is to estimate the mean value of the dependent variable from the known value of independent variable. Now we can consider, or now we can examine, how can we form a population regression function with the help of an imaginary table. Consider the table. In this table, the family income and expenditures of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 families are given. These 12 families are grouped into 3 different income groups. Under each income group, there are certain families having different income. For example, under the 100 income group, there are 3 families having 5, 50, 60 and 70 rupees as their expenditure. Under 200 rupees, with 200 rupees, there are 4 families having expenditure of 90, 100, 110 and 120. Like there are 5 families under the 300 income group. This table thus shows the conditional distribution of expenditure, or the conditional distribution of y given the income or given x. That is, the table shows the conditional distribution of y, the conditional distribution of y given x. When x is equal to 100 is the condition, y shall take 3 values 50, 60 and 70. So the table shows conditional distribution of y given x. When x is equal to 200, when x is equal to 300, the different values taken by the consumption expenditure y is shown by this table. So once more we can say this table shows conditional distribution of y given x. When we plot these combinations, we get a scattered diagram. Consider the scattered diagram. It shows a trend. The scattered diagram shows that the average expenditure increases. The average expenditure increases as income increases. When we plot these combinations, we get a scattered diagram. Consider the scattered diagram. It shows a trend. The scattered diagram shows that the average expenditure increases. The average expenditure increases as income increases. The next step is calculating the conditional probability of the dependent variable given the independent variable. From the data or from the table, we can calculate the conditional probability of y given x. that is the probability of y, that is the probability of y given x, the p of yi given xi. For example, let us calculate the conditional probability of y given xi, or the probability of y to be 50 when x is equal to 100. The probability of y is equal to 50 when x is equal to 100 is equal to 1, 2, 3 is equal to 1 by 3. Like we can calculate the conditional probability of y to be 140 when x is equal to 300. That is the probability of y is equal to 150 when x is equal to 300 is equal to 1, 2, 3, 4, 5, 1 by 5. Now you have learned how can we calculate how the conditional probability is calculated. And on the basis of or with the help of this conditional probability, we can calculate the average value or the mean value or the expected value of the dependent variable. For example, the expected value of the dependent variable y given the income or x is equal to 100 will be the conditional probability into 50 plus 60 plus 70 is equal to 180 by 3 is equal to 60. That is the expected value or the mean value or average value of y when x is equal to 100 is equal to 60. We can calculate the expected value of y given x is equal to 20, given x is equal to 30, etc. And the expected value of y in this scattered diagram. And in this scattered diagram, this straight line shows the expected value of y given xi. This is the expected value of y given xi. And the expected value of y given xi or this line is known as population regression line or the regression line of y on x or the regression curve. This line E of y given xi is known as population regression line or the regression curve or the regression line of y on x. Here you can see that the expected value of y given xi is a function of xi. It's a fact, it's very evident that, but it's very clear that the expected value of y given xi is a function of xi. And this is known as population regression. Let us conclude by stating the different steps of involving in the calculation or in the forming of the population regression function once more. First we collect a data, and on the basis of the data we form a scatter diagram, and we calculated conditional probability, and we calculated the conditional mean or the expected value, and we form the population regression function. Okay?